Hi, welcome to this video. In this video, we are going to evaluate this integral, double integral from 01 to 01 dx dy over 1 minus product of x and xy. So is set as I integral. So the first thing we should know about the double integral, we have two double variables, x and y. Another thing we should know about this form of this integral, this is similarly to the series, geometry series. Geometry series is writing as this form, x the power of n equals 0 plus infinity equal 1 minus x power of n plus 1 over 1 minus x. The x is an inferior of 1. It should be smaller than 1, larger than minus 1. Okay, so this one looks like this one. How gonna transfer this form of integral to the series, to geometry series? So in order to do that, we can put the substitution, u substitution, like you can put x y equal u. We are going to differentiate this one, but remember, y will be the variable, the x will be the constant. So this one du equal x dy. So dy, we're going to replace dy equal du over x. Okay, but we have a boundary, the bound 0. So that's mean, let's put, if y equals 0, that's mean u equals 0, y equals 0. If y equal 1, that's mean u equal x. We are going to change that from 0 to 1. We're gonna leave x as is it now, because the x, we're gonna leave it for later. We're gonna work on the integral and dt variables. So this one become 0x dx. We're gonna leave dx outside because the dx is a whole thing. So we're gonna change just dy. Dy will be 1 over x dy over 1 minus u. Okay, du, this one changed to du because we are working on du now. Du, this one dx outside. We're gonna take 1 over x outside because it's a constant in this case for this integral. So our integral become 1 over x. Okay, 0x from the bounds from 0 to x equal du 1 over u dx. We're gonna calculate this integral. What's this integral equal? Let's take it out and then calculate it separately. So let's call it g integral from 0x du 1 minus u. What is one equal? Exactly the same thing for the geometry series. Geometry series, this one limits x with n plus 1 equal 0 when n approach infinity. Okay, this is the condition. This one has to be smaller than 1, inferior than 1. Okay, in order to get the limit of x of the power of n equals 0. That's what happened here now, because here the u, keep in mind, u is larger than 0 and smaller than x. Okay, because as this integral show here. So what is this one? This one exactly this one. 1x. Let's put it in separate. This one exactly is the sum of this one. So the sum, this one from 0x, this is sum of u power n, and from 0 this infinity. Don't forget this is the integral du. So this one is a constant, you can put the sum outside. Okay, you can put it in this one, switch the integral 0x un du from 0 to plus infinity. What is this? This is easy to calculate now. This is 0, this is 1 over n plus 1 un plus 1 from 0x, always n infinity. This one, this is we have the rule of the integral of un is always we are looking for the original function. Original function, this one is a 1n plus 1 un plus 1. If you derivate this one, for example, let's derivate this one, 1n plus 1 un plus 1, differentiation, because derivation for this one equal 1 plus 1 multiplied by n plus 1. This one un plus 1 minus 1. They can cancel out 1 and 1 here. This one cancel out, it become un. It is the same exactly what we have here. So we don't need now, for now, this one. Okay, so this one now become, we can take it outside here, 1 plus 1 from n 0 infinity. Okay, this one can put it separately, plus 1 from 0 to x. This one n equals 0 plus infinity, 1 over n plus 1. un plus 1 replace, we log into un by x here, so become x, the power of n plus 1 minus 0. So this our integral become x power, x here, it can become power of n plus 1. Okay. Okay, this is our integral now. This one we're gonna replace it with here, what we have in our I integral. So let's do it now. So our integral become I from 0 to 1, 1 over x. I'm gonna put this one exactly here, as is it. So the sum of 1 plus 1 from n equals 0 plus infinity, x power of n plus 1 dx. We always have integral of dx here. So we're gonna take this one outside as a constant, out of an integral. So our new integral become here. So 1 over, so you're gonna become a sum of 1 of n plus 1, okay, 0, 1, 1 over x multiplied by x n plus 1 dx from 0 plus infinity. This one become 1 over n plus 1 plus infinity. This integral, we're gonna cancel out x here, become x the power of n dx. Now this is easy to calculate. This one, what is this? It's the same what we did before here. It's the same thing. So I equal the sum of 1 n plus 1 from n equals 0 plus infinity. So this one become 1 over n plus 1 x n plus 1 from 0 to 1. So our angle become 1 over n plus 1 square, because we took in again this one outside. n plus 1 over n, multiply by 1 over n plus 1 equals 1n plus 1 square, from always from 0 to infinity. So this one is a x n plus 1, that means 0. You can put it straight, 1 over n plus 1 minus 0 equal the sum of, this is 1 over square, the power of n plus 1 equal 1 minus 0, that means 0. So this one, our sum will become this one, n plus 1 square from n plus infinity. You can write this one again in this form, 1 over n, but this one, if you put 0 here, become 1. If you put 1, equal from 1 plus infinity, okay, square. What is this? This is pi square over 6, okay. This one pi over 2, pi square pi square 2 over 6. How we gonna prove that? We're gonna prove it later, do not know. This is always equal this one. This one gonna become, like, we're gonna apply the series Fourier or the Taylor expansion, okay. Now there you go, our integral become pi square over 6. Thank you. If you like this video, don't forget to subscribe. Thank you. I see you in next video.